Hello guys, today we'll be learning about logarithms or logs for short. So, what is a log? Well, a log is basically an inverse function to exponentation. It is a mathematical expression that asks about how many times a base of b, needs to be multiplied in order to get a particular number. If, for example, x is a logarithm of n to the base of b from b to the power of x equals to n, then the expression can be written as log base b over n. What if, let's for example take 2 to the power of 3, what will be its value? Its value is obviously 8 because 2 times 2 times 2 will equal to 8. 2 to the 4, 4 to the 8, so yeah, it is 8. Now, if I ask for log base 2 of 8, then what do I mean by that? And what will be the answer? Here, we need to find out how many times the base, the base, needs to be multiplied in order to get 8. In this case, we need to multiply 3 twos. Here, 3 twos. So the answer for log base 2 of 8 will be 3. Let's try another example. If I ask for what if I ask for log base 3 of 27? Then what will be the answer? Now, as you can see, our base is 3 and the number 27, which is also known as argument, which is also known as argument, and this is known as base. And 27, which is also called argument in here, is our question for finding out how many threes needs to be multiplied by itself to get 27. How many threes needs to be multiplied to get 27? So let's multiply. One three, three threes are 9, and 9 threes are 27. 3 it will be 9, and multiply that with 3, it will be 27. So we'll get 27 here if you multiply 3 threes. So log base 3 of 27 equates to 3. Log of 10. What will be the answer for this? As you can see, there is no base at all. How can we solve? Well, you have to remember one thing. If there is no base in a logarithm equation, then we have to assume that the base of log is 10. Therefore, in this case, the answer to log base 10 of 10, not this, the answer for that is 1 because, well, 10 to the power of 1 is just 1. So now, what if you had log of 5 of 1? Now remember, when the exponent of any number is 0, then the answer to that is 0. Now with that in mind, we can easily say that 5 to the power of 0 equals to 1, just 1. So here our exponent is just 0. So the answer to this equation is just 0. You can also think logically. How many 5s needs to be multiplied in order to get the argument of 1? None, right? Exactly. So you can simply put 0 in here. Let's try to do something else. Let's try log base 4 of 1 by 16. If you remember how to get the answers for negative exponents, then it will be easy to solve. We know that 4 squared equals to 16. But what is the value of 4 negative 2 to the power of negative 2? In fraction form, that will be 1 divided by 4 to the power of 2, or basically 16, 1 by 16. So we already got our answer, that is the negative 2. So the log base 2, log base 4 of 1 by 16 is negative 2, because we need my negative 2 fourths in order to get 1 by 16. So this is the answer. Now let's talk about the natural log, which can be expressed as ln. So what is the difference between ln and our normal log? The difference is that a normal log has a base of 10, which is not fixed or permanent though, because you could have other bases as well. So it's not fixed. It can have 2 or 5, though you have to assume it is 10 if there is no base written in a normal log. On the other hand, a natural log contains only one fixed number, which is called Euler's number. Euler's number, which is denoted as E. And just like pi, Euler's number is also irrational, meaning the value can continue on forever without a complete pattern. Some of the digits of Euler's number is 2.7182881 and so on forever. Now, when writing the natural logs, you don't need to write e in the base of a natural log. Denoting the natural log by just an can work as well. It is enough for anyone to understand. Now let's learn about some properties or formulas of logarithm. If we have a log a plus log b, log a plus log b, then that will be equal to log sorry log ab. That will be equal to log ab. For example, say we have log base 2 of 8 plus log base 2 of 16. Now we can combine the logs and multiply 8 with 16, which is equal to log 2 8 times 16, which will be equal to log 2 of 128. Now if you multiply 2 2 times 2 4, 4 2 is 8, 8 2 is 16, 16 2 is 32, 32 2 is 64, 64 times 2, which is 128. So we need 7 fours, 7 twos to get this number 128. We need 7 twos. Therefore, log base 2 of 128 will be equal to 7. Log base 2 of 128 will be equal to 7. Now, this can be applied if the bases of the logs are the same. If the bases are different, then we have to improvise. I'll teach you about how to solve logs with different bases in my next video, which will be about solving logarithmic equations. Now, how can we be sure about this result? How can we prove it? Well, let's try to solve it another way. So, as you can see, log base 2 of 8 plus log base 2 of 16. As you can see, here too, we need 3 twos multiplied to get 8. So, which can be written as 3. Plus, we need 4 twos to get this number 16. So 3 plus 4, which also equates to number 7. Now, if we subtract log A with log B, then we'll combine the logs, that is, if the bases are the same, and divide them by A divided by B. Now, let's say we have log, let's say we have log 3 of 27 minus log 3 of 9. The next thing you have to do is combine the logs and divide 27 with 9, which will be log 3 log 3 27 divided by 9. Now, dividing 27 with 9, that will be equal to 3. So log base 3 of 3, which is just 1 because 3 to the power of 1 is just 3. To prove that log base 3 of 3 equals to 1, we can simplify log base 3 of 27 to log base 3 of 27 minus log base 3 of 9. We can simplify that to, well, 3 3s and 9 and 3 are 27, which is 3 minus log base 3 of 9, which is 3 3s and 9. So we need 2 3s. That will equal to 1, which is our exact answer. Another thing you need to know is that if an argument of a log contains an exponent like log base of c over a to the power of b, then that can also be written as log, sorry, that can also be written as b log base c of a. Now, we can prove that as well. Let's say we have log base 2. Let's say we have log base 2 of 4 to the power of 2. Now, the next thing you have to do is taking the exponent over here, which will be equal to 2 log base 2 of 4. Now, we know that 2 times 2 equals to 4. So, log base 2 of 4 is just 2. That will be 2 times 2. Now, multiplying that, we'll get 4. To prove this, we can just write the integer form of, we can write the integer form of 4 to the power of 2, which is 16. Which is 16. And we know 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. We will need 4 2's multiplied together to get 16, which is the exact answer. Hence, we proved that they are equal. Now, most likely, your teacher or professor may not give you these questions like proving them. I only wanted to make you understand better. After all, it is better to understand than to memorize. Now, if we have log a of b equals to c, Then taking base a to the exponent of c will be equal to b equals to a to the power of c. A to the power of c. Take log base 2 of 4 equals to 2. Now taking 2 to the other side, this will be equal to 4. So 4 equals to 2 to the power of 2, which is true. The last thing I want to show you is that, say we have log base a of b. Now that can also be written as log base c of b divided by log base c of a. That is equal to all this. Now, base of c won't matter in this case. It can be any number, 3, 2, 5, etc. If the bases are the same from numerator and to denominator, then our answer will work. Now, say we have log base 5 of 4 divided by log base 5 of 2. This can also be written as log base 2 of 4. Log base 2 of 4. And this basically equals to 2. And this marks the end of our part 1 series about logarithms. Thank you very much for watching. I'll see you all again.